So for hyperbolas, first off, these are our goals, to graph and write equations of hyperbolas. So we're going to see equations now where there's not a plus sign, there's a minus sign. And we're going to actually get this down. How do we get something that looks like this in standard form? Again, you'll get the chance to write this down later. So I'm going to go on to the next slide. Let's get these definitions down today. A hyperbola is the set of all points P such that the difference of the distances from P to two fixed points called the foci is constant. So any point on this hyperbola, here's what I mean by D1 and D2. If you took the difference of the distance of the first distance minus the second distance, it's going to match if I took a point up here in this corner. These two distances minus each other would also be the same as the previous. They're equal. More definitions. The line through the foci intersects the hyperbola at 2 points, and these are the vertices. The midpoint is the center of the hyperbola. There are two things about the graph. A hyperbola, as we know before, have two branches, and it has two asymptotes. And that doesn't change when we talk about hyperbolas here. We're going to have two branches that are going to be symmetrical and two asymptotes. Next slide. This is on page 615. This is very overwhelming to look at all at once. So something that I like to stress is what looks the same in both. What looks the same, or what do you see the most in both? We're going to start with this equation, y squared over 9, or y squared divided by 9, minus x squared divided by 25 equals 1. If I see that 9 is underneath the y squared, then the square root of 9 is going to be plotted on the y-axis. And that's what I graph on the y-axis. Let's also note that A develops our vertices. So B is going to be the square root of that 25. So I'm going to plot on the x-axis 5 over on both ways from the center. Ellipses had vertices and co-vertices, but this B does nothing for us except create a box. We're going to start creating our box, and we're going to have a box that goes through each of these A's and B's that we have. It's got to be a rectangle going through them. Create these asymptotes. We're going to create an asymptote by going through the diagonal of this rectangle on both ways. Create a diagonal going through each diagonal of the rectangle. So creating a diagonal going through the diagonal of the rectangle, this develops our asymptotes. Our hyperbola will not cross these. Our hyperbola will be formed by these. We need to find our focus. Our focus is found by taking c squared equal to a squared plus b squared. So our focus distance will be equal to 9 plus 25, or 3 squared plus 5 squared. Nine and 25 get you 34, and taking the square root of 34, it's a little bit below 6. That focus should be graphed a little bit below 6 on that y-axis. There we go. And why did I plot the foci on the y-axis? That first fraction tells you your main axis that you'll be concentrating on. So the foci and the vertices are both on the y-axis. I can create my hyperbola going towards those asymptotes. In homework, it's going to ask you also if you could figure out the equations of these asymptotes. And to find an equation of one of these asymptotes, it deals with that slope of, well, we go up 3, right 5. So the slope would be up 3 over 5x, or 3/5 x. And our y-intercept is 0, so we'd have plus 0. We're just going to keep it basic. The other way is going to be the opposite of 3/5. We're going to try this again. Okay, like before, I'm going to have my a squared always goes first. So my a is going to be the square root of that 16. Square root of 16 will be 4. And since that is below the x, I'm going to go on the x-axis 4 over both ways. Those will be my vertices. So my foci will also be on that same axis. Now, to create my box, I'm going to use this b squared. Since b squared is 9, just b is going to be the square root of 9. So I'll move 3 up and 3 down from the center 0, 0. Let's create our box, or our rectangle, that goes through each of them. And it should have a length of 8 by 6. Should be a rectangle 8 by 6. We can create our asymptotes by going through each of the diagonals. To find where our focus is, we're going to use c squared equals a squared plus b squared. A squared will be 16. B squared, since b is 3, b squared will be 9. So our focus distance will be on the x-axis going right and left 5. And for this asymptote, because the intercept is 0, we're not going to put the plus 0 on the end. The only thing different between these two and ellipses is this minus sign. So we're going to practice writing it in standard form, whether we have coefficients or whether our coefficients look like fractions, and what do we do with these. The strategy whenever you have coefficients and no fractions, this equal sign, or this side of the equal sign, needs to equal 1, especially in a hyperbola or an ellipse. So in order for this side to equal 1, I have to divide both sides by 36. So to reduce this fraction, 4 goes in the 36 9 times. So the ending answer for this will be y squared over 36 minus x squared over 9 equals 1. In a similar fashion, in this next example, in order to get this 4 to be a 1, I'm going to have to divide both sides by 4. But in order to attack this fraction, instead of dividing by 4, I'm going to multiply both sides by 1/4. When we distribute this 1/4, we get y squared over 4 minus we're going to be taking this 4 times 36. And this right side is equal to 1. Going back to that first slide,